Why use Python's OS module methods instead of executing shell commands directly? I am trying to understand what is the motivation behind using Python's library functions for executing OS-specific tasks such as creating files or directories, changing file attributes, etc. instead of just executing those commands via os.system or subprocess.call. For example, why would I want to use os.commod instead of doing os.system, commod ... I understand that it is more Pythonic to use Python's available library methods as much as possible instead of just executing shell commands directly. But, is there any other motivation behind doing this from a functionality point of view? I am only talking about executing simple one-line shell commands here. When we need more control over the execution of the task, I understand that using subprocess module makes more sense, for example.
There are 4 strong cases for preferring Python's more specific methods in the OS module over using os.system or the subprocess module when executing a command. Redundancy: spawning another process is redundant and wastes time and resources. Portability: many of the methods in the OS module are available in multiple platforms while many shell commands are OS specific. Understanding the results: spawning a process to execute arbitrary commands forces you to parse the results from the output and understand if and why a command has done something wrong. Safety: a process can potentially execute any command it's given. This is a weak design and it can be avoided by using specific methods in the OS module. Redundancy: see redundant code. You're actually executing a redundant middleman on your way to the eventual system calls, chmod in your example. This middleman is a new process or subshell. From os.system. Execute the command, a string, in a subshell. And subprocess is just a module to spawn new processes. You can do what you need without spawning these processes. Portability: see source code portability. The OS module's aim is to provide generic operating system services, and its description starts with, "This module provides a portable way of using operating system dependent functionality." You can use os.lister on both Windows and Unix. Trying to use os.system/subprocess for this functionality will force you to maintain 2 calls, for ls/dir, and check what operating system you're on. This is not as portable and will cause even more frustration later on, see handling output. Understanding the command's results. Suppose you want to list the files in a directory. If you're using os.system, ls/subprocess.call, ls, you can only get the process's output back, which is basically a big string with the file names. How can you tell a file with a space in its name from 2 files? What if you have no permission to list the files? How should you map the data to Python objects? These are only off the top of my head, and while there are solutions to these problems, why solve again a problem that was solved for you? This is an example of following the don't repeat yourself principle, often referred to as DRY, by not repeating an implementation that already exists and is freely available for you. Safety: os.system and subprocess are powerful. It's good when you need this power, but it's dangerous when you don't. When you use os.lister, you know it cannot do anything else other than list files or raise an error. When you use os.system or subprocess to achieve the same behavior, you can potentially end up doing something you did not mean to do. Injection safety: see shell injection examples. If you use input from the user as a new command, you've basically given him a shell. This is much like SQL injection providing a shell in the DB for the user. An example would be a command of the form. This can be easily exploited to run any arbitrary code using the input, nasty command, hashtag to create the eventual. There are many such commands that can put your system at risk.
For a simple reason, when you call a shell function, it creates a subshell which is destroyed after your command exists, so if you change directory in a shell, it does not affect your environment in Python. Besides, creating subshell is time-consuming, so using OS commands directly will impact your performance. Edit. I had some timing tests running. Internal function runs more than 10 times faster. Edit 2. There may be cases when invoking external executable may yield better results than Python packages. I just remembered a mail sent by a colleague of mine that performance of gzip called through subprocess was much higher than the performance of a Python package he used. But certainly not when we are talking about standard OS packages emulating standard OS commands.
it is safer. To give you an idea, here is an example script. If the input from the user was test rmrf, this would then delete the home directory. This is why it is safer to use the built-in function. Hence why you should use subprocess instead of system2.
Shell call are OS specific, whereas Python OS module functions are not, in most of the case. And it avoids spawning a subprocess.
This wasn't much alignment, sorry.